Hello everybody, these are the video notes for the 3.3 homework, where we are going to be going over some of the features of functions. We have a graph here, and then a table of features that we're going to fill out, and then we have all these different labels that we're going to drag onto our graph to annotate it. First is the domain, and you'll remember from an earlier lesson that the domain is all the possible x values that we see in the function or in the graph. So if we go furthest to the left, we'll get to this point here on the left, and then furthest to the right that this graph goes would be to right about there, this point right here. And we want to look at the x value, so let's just look at the x-axis. So the furthest to the left is -10 on the x-axis, and the furthest to the right that this function goes along the x-axis is 7. So if we write this in interval notation, I'm going to use closed brackets because we are including the endpoints, an x of -10 to an x of 7. That's my domain. And I'll go ahead and color code this red. Next is the range, and the range is all of the possible y values for the graph. So I'm going to look at the lowest possible point I see on the graph, that's right here. And then I'm also going to look at the highest possible point that I see on the graph, that's up here. I'm going to drag this so it matches up with those points. And so now we're talking about y values. So that lowest point has a y value of -3, and the highest point has a y value of +7. So in interval notation, I'm going to write -3, 7. And I'm using closed square brackets again because we are including the endpoints. The endpoints are filled in on the graph. Color code that blue. The next feature is the minimum of the graph, and that's the lowest possible y value, right? The lowest that the graph ever goes. And I'll drag this arrow over here because that's our minimum, and that y value is -3. So we'll put a -3. So remember, minimum and also maximum, it's referring to the y values. And the maximum would be the opposite of that. What is the highest point? And in this graph, the highest point, the peak, is going to be right here. And we want y values again, and so that y value of this point up here is 7. So I'm going to put 7 there. And notice that the minimum and maximum values are the same two numbers in my range. Next is increasing intervals. Increasing intervals are wherever in the graph you notice a positive slope. Or I like to think of it as if you're walking along the graph going from left to right, anytime that you're going uphill, that's when is an increasing interval. So let's go ahead and drag these annotations. We have one increasing interval here. And another increasing interval right here. On increasing intervals, as x is increasing, y is also increasing. And we want to write our increasing intervals referring to the x values. So the first increasing interval right here on the left starts when x is negative 10, and then it keeps going up, 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 and then it stops increasing when x is negative 8, right? Because then it switches to going downhill. So my first increasing interval is from an x of negative 10 to an x of negative 8. And with increasing and decreasing intervals, you're always going to use open brackets, the round brackets. And the reason why we always use open brackets is because the function is not actually increasing at those very endpoints, only in between those endpoints. And the second interval that's increasing, so I'm going to use a u, because in math the u means and. The next increasing interval starts when x is 4. That's when we start walking uphill again. And we're walking uphill all the way until we get to the very end, which is an x of 7. So it's increasing from an x of 4 to an x of 7. So my interval will be 4, 7. So these are my two increasing intervals. Next is my decreasing interval. So that's whenever I have a negative slope on the graph. I can also think of it as if you're walking from left to right, whenever you are walking downhill, that is when the function is decreasing. So that's this middle section right here. That's the part that's decreasing. Okay, so between what x values are we walking downhill? Well, we start here, so this is an x of negative 8, until we get to walking downhill, 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 until we get to an x of 4, and that's when we start walking uphill. So the decreasing interval is from an x of negative 8 until an x of 4. Notice again, I'm using open round brackets because we don't include the endpoints when we're talking about increasing and decreasing intervals. Alright, next, the y-intercept. You'll recognize that term. That's where the graph touches the y-axis. Right, it's when x is 0, where is the function? Let's go ahead and drag the y-intercept label. Oops, sorry. Sometimes it might be easier just to click on it and then use the arrow keys to get it exactly where you want. That's what I'm doing right now. Alright, you might not be able to get it exactly where you need to be, but that's close enough. Right, this is where the line crosses the y-axis. And the value of that y-intercept is 0, 1. And then the x-intercept is wherever the function touches the x-axis. And in this graph, we have two of them. One is right here, when the graph touches the x-axis, and another one is going to be further to the left. Right there. So those two x-intercepts, one is approximately at negative 9, 0. It's not exactly there, but it's close enough for us. And these, we're writing xy coordinates here. 4, 0. An x of 4, a y of 0. And these are the features of our function. After you have all of this down, you're going to complete the remaining 3 slides. And this is set up so that once you've completed the table, you can then check your work by clicking on this black box or this gray box, and then if you delete it, you'll notice that it will reveal the correct answers so that you can check your work. But make sure you do the work first and then check the answers, because if you just look at the answers, then you're not really learning.